So when it comes to set applications, say statistics, statistics revolves around set theory, and then comes probability, which depends on elements of the set. So the bridge between sets and probability, which leads to inference, is cardinality. So for instance, if someone is studying the types of trees in this county, well, I can't sit and write every single tree out, even if you exclude repeating species. There are plenty of trees. So if we want to understand trees, I don't care about writing them out. All I care about is the number of trees of a certain kind that are in this county. So the cardinality becomes very important in terms of practical applications, particularly in statistics, where we find probabilities, then infer using those probabilities. So I'm going to start with a simple case where I have two sets, perhaps the universal set, set A, set B, and I'll put three different regions: region 1, region 2, and region 3. Are these sets, are the sets A and B disjoint? No, because we have an overlap right there. So clearly they are not disjoint sets. If I want to pick the region corresponding to, A intersect B, which one would I pick? 1, 2, or 3 in Roman numerals? I will pick the one that I just shaded, number 2. Suppose we want to find the region corresponding to a complement. We want to select all regions that would correspond to a complement. So the answer is regions 3 and 4. A common mistake that students would make is to include 2. Do keep in mind that a complement would correspond to all elements that are not A. No part of A. Region 1 is a part of A. Region 2 is a part of A. By all means, A is formed by combining regions 1 and 2. So we cannot include 2 when we write a complement. The answer here is 3. couple of ways in which one may deduce this. You can either use literal expressions, or you can use the graph or the Venn diagram. I shouldn't call it graph. So I have the sets listed. Now I'm going to start shading. First, I want to come up with a complement. So pick a color, perhaps go with that. Of course, there are other theoretical ways, but I'm not going to cover those here. It's beyond the scope of what we're doing. All of that would be a complement. Now we have to find B or shade B, and then pick the intersection of the two. And naturally, one can see that the intersection of the two is region 3. Of course, there is another way to do it which doesn't require sketching. Wouldn't recommend, if you aren't an artist, the sketching part. We know we wrote a complement from earlier as region 3, region 4. We know B is region 2, region 3. We simply want to find the intersecting regions. I don't want to put it as a set. We'll just put parentheses. In a very intuitive way, sure, they are sets, but I don't want to do that. I want to find whatever that's common between the two. Well, I have that and that. So the result has to be region 3. We are going to write the cardinality of the sets. So there are a couple of ways to do this. I'll show you how one can do this with writing out the regions, but it's not necessary with practice. You can simply find the total. Keep in mind, the purpose of cardinality is to put them together and get to probability and make inference. There is no need to explicitly write the elements out. What we want in practice is the cardinality. Okay, first, let's find the regions corresponding to U. Let's see, the set regions U, A, B, A intersect B. So U, A, B, A intersect B, A union B, A complement, B complement, and A complement intersect B complement. Well, U contains all regions, so 1, 2, 3, 4. That would mean I've got to combine all the elements. So 5 plus 3 plus 11 plus 7. That would give me 26, the total. For A, we will have regions 1 and 2. That would simply mean I'm going to add 5 and 3. That will give me 8. For B, I would have 2 and 3. So 3 plus 11, I got 14. The region that is common to both A and B is region 2. So I will have 3 elements. The region that is, or that would correspond to A union B is 1, 2, and 3. So if you add those counts, we would have 19. A complement would simply contain everything that is not A. So you refer back to U and you will naturally see it is 3 and 4. The elements, if you add them, you get 18. Regions that are not in B would correspond to B complement. So 1 and 4, because region B, the regions for B would be 2 and 3. So 1 and 4, 5 plus 7, we've got 12. Lastly, we want to see what is common between A complement and B complement. The region that is common is region 4, and region 4 simply has 7 elements. We are going to do that problem right there. The one on domestic and international travelers. It is number 40 in your text. While you take a quick note, I am going to take a quick note here as well. I'll call the problem as travelers. This is an application problem with 2 sets. So we have 3 regions corresponding to 2 sets. The sets are A and I. I would correspond to international travelers. In total, we have 1510 domestic and international travelers. And those travelers were asked a statement if they agree or disagree with the following statement. It is a good idea to buy flight insurance before embarking on a trip. The result of the survey showed 440 people agreed with the statement that it is a good idea to buy flight insurance before embarking on a trip. 260 international travelers agreed with the statement that it is a good idea to buy flight insurance before embarking on the trip. And what they have given us is out of the 1510 total travelers, we've got international travelers to be 770. So I have summarized the information from the problem. We have 1510 domestic and international travelers, and we have a statement. The statement that we posed is it is a good idea to buy flight insurance before you get on a trip. And we want to know the number of people who agreed and the number who disagreed. We have a few bits of information that we have in the problem. 440 people, travelers, agreed with the statement. 260 international travelers agreed with the statement. The number of international travelers that we sampled or observed, 770. So before we start answering the two problems, we are going to summarize the sets, the corresponding regions, and the cardinality for each of them, just like the previous problem. In the previous problem, I gave you the counts. Here, we are going to come up with the sets, the regions corresponding to the sets, and the counts. So we want to identify the regions corresponding to each set. Well, the universal set must contain all regions. So I'm going to put 1, 2, 3, 4. The set A would contain regions 1 and 2. The set international would contain, oops, my bad, wrote it backwards. A would be 2 and 3, international 1 and 2. We can now write the cardinality. U would correspond to the set of all travelers. We have in total 1510. And A would be those who agreed. So I'll write the meaning on this side. So total number of travelers, which would include both domestic and international. The set A would correspond to travelers who agreed with the statement. Third, number of international travelers. So set A contains regions 2 and 3. The cardinality is given to us, 440 people. International would be the 770 that is given to us. The region would be 770. Okay, so we have the set A complement. We want to write its regions. then identify its cardinality, then come up with its meaning. So cardinality is the most important aspect here. First, we'll identify the region. A complement will contain regions that don't belong to A. So the regions that don't belong to A are regions 1 and 4. So we have to exclude the count of A altogether to get the counts for a complement, because I'm excluding all elements that correspond to A from the universal set. So the universal set has a cardinality of 1510. I'm excluding all elements corresponding to A, so 440. That would give me 0, 7, 10, or 1070. I'm simply subtracting 440 from 1510. Now, what would this 1070 correspond to? We've got to be careful in interpretation. The set U corresponds to all travelers, domestic and international. The set A corresponds to travelers who agreed, which would mean the set A complement would be everything that is not A. So that would simply be travelers who don't agree. So we're just going to the opposite of A. The set A is travelers who agreed, which would mean not A would be travelers who don't agree. But then we are just talking about travelers. We're not specifically talking about international travelers. So that would include both domestic and international travelers. Okay, so we want to find the complement of the set int, international travelers. So every region that is in int shouldn't be in int complement. So 1 and 2 are in int. That would imply 3 and 4 have to be in its complement. Well, if 3 and 4 are in complement, we have to exclude the counts of 1 and 2, which would simply correspond to 770. So 1510 minus 770, that would be 40 and 740. So we are going to the opposite of the set int. In other words, not whatever set int represents. So int represents international travelers. So not international travelers would mean domestic travelers. So we will have domestic travelers. I would like to go back and fix something here. Didn't mean to write it as total number of travelers, sort of went with the cardinality part. I'm trying to write the meaning of the set. So going to change that to all travelers, domestic and international. Int would be the set of international travelers. I got way too excited when I wrote the cardinality and just kept on writing. So I want to write the meaning of the set. So you would be all travelers, domestic and international. And so forth. So it is provided in the problem that 260 international travelers agreed. So the number is 260. It is given to us. It will correspond to region number 2. So we are going to go with the picture here. Now we have region 1 and 2 that would correspond to international travelers. So the middle part is the part that corresponds to international and agreed. International travelers who agreed. So that, and region 3 would include all people who agreed. First region, all international travelers. Oops, damn it, it's not working. Okay, now in the problem, it was given to us that the number of international travelers were 770 in total. Out of those 770, 260 of them were international and agreed. The number of people who agreed was 440. So if I want to write only the count for region 1 and region 3, I have to take away 260 from the 770 that I have. And that would give me 510. Why so? If I put 510 and 260 together, I will get all international travelers. That would be 770. Now, off to the other side. We have the information that 440 people agreed with the statement. Well, if the total number of people who agreed is 440, and if I already accounted for 260 who are international and agreed, I have to subtract 440 minus 260. That would result in 180. So A Union International would now consist of the counts 510 plus 260 plus 180. So that would be 770 plus 180. We get 950. So our answer for A, Union International, the regions would be 1, 2, and 3. And we have 950. What will that correspond to? All international travels who and all who agree. So total number of all those who agreed. Oh, all those who agreed. That would include domestic and international, combined with all international travelers. Mind you, we're not saying these are the number of international travelers who agreed. We are saying international travelers, all those agreed, put them together. Now that we sorted out 950 travelers, we know what we will have in region 4. So we have to subtract the 950 from 1510, excuse me. Oh, never mind, that is correct. 950 from 1510 to get region 4 count. That would give us 560. So let's sort of go for a complement and international complement. So we want to find a complement intersect the international set complement. We already know the regions in a complement are 1 and 4. The regions in international complement are 3 and 4. So what's common is region 4. Well, region 4 has a count of 560. We just found that. So I'm just going to go ahead and put 560. Next, a complement would mean not A, which would mean not international travelers. So domestic travelers. Sorry, I put it backwards. Not international complement would mean not international, which would imply domestic. The set A would mean agree, not A would mean disagree. So domestic travelers who disagree. So you have a domestic traveler and the person or people also disagree. And let's find A intersect and complement. So we want to find the region, the count, and the meaning. Okay, so we know the set A contains regions 2 and 3. The set int contains 1 and 2. Int complement contains 3 and 4. So we look at what's common between 2 and 3 and 3 and 4. We have region 3 in common. And we simply have to find the count for region 3, which we already did. So 180. What does A mean? A would mean people who agreed. Int complement would mean not international travelers, so domestic travelers, as the individuals are domestic travelers, and they agreed. It is and because we're doing intersection. So the last part, the meaning would be domestic travelers who agreed.